Section 3.8, implicit differentiation. In this section, we are going to find y prime for the implicit function. For example, if you have y equals x squared minus 3x, this function is called explicit function because y is on the left-hand side and the right-hand side is in terms of x, or another way we call it y is by itself. For the case that you have natural log y plus the tangent of x equals e to the secant of the y. For this situation, y is not easy to be solved, or maybe it cannot be solved at all. This case we call the implicit function. And our goal is to find y prime for the implicit situation. The procedure to find the derivative. Step 1. Differentiate both sides of the equation with respect to x, treating y as a differentiable function of x. And this process, we are going to use chain rule. Like consider as the inner-outer functions. Step number 2. We collect terms with dy by dx or y prime on one side of the equation and solve for dy by dx or y prime. Examples. We are going to find dy by dx of the given function. Part A, we have x squared plus y squared equals 1. And this is the equation of the circle with the radius 1 and the center at 0, 0. We know the order pair here is 1, 0, 0, 1, negative 1, 0, 0, negative 1. The derivative we call is the slope of the tangent line, and we will come back to the diagram after we find the dy by dx. Step 1. We are going to find the derivative with respect to x on both sides. So d by dx of each term, dy by dx of x squared, d by dx of y squared equals d by dx of 1. The derivative of x squared with respect to x is 2x. Derivative of y squared is 2y. Recall, we treat y as the function of x. And this part, the chain rule comes in. The right-hand side, the derivative of the 1 with respect to x, which is 0. Step 2, we are going to find y prime or solve for y prime, which is dy by dx. We see the second term contains dy by dx. We leave 2y multiplied by dy by dx on the left-hand side and subtract both sides by 2x. So we get the right-hand side as negative 2x. And next, we divide both sides by 2y. So negative 2x divided by 2y. And simplify to be negative x over y, which is the slope of the tangent line at the point on the curve or on the circle graph. For example, at the order pair 0, 1, the slope is 0. We can prove it by using the slope or the dy by dx as negative x over y. The x is 0 and the y is 1, therefore the slope is 0. And for any order pair, for example, the order pair located on the fourth quadrant, like positive 1 over 2 and square root 3 over 2. With the negative sign for the y value. The slope, we see the tangent line is the rising line or the increasing line. So we expect to get the slope positive. So the m tangent for the point on the fourth quadrant is negative x divided by y, which comes out to be positive 1 over square root 3 as expected. This example, we have 2 square root x minus the cube root of y equals y. Your goal is to find y prime or dy by dx. Step number 1. we find the derivative with respect to x, both sides of equation. So d by dx of 2, and we write square root x as x to the power 1/2 minus d by dx. We write the cube root of the y to be y to the power 1/3 equals d by dx of the y. The derivative of 2x to the 1/2 is 2 times 1/2 x to the negative 1/2 minus y to the 1/3 is 1/3 y to the negative 2/3 multiplied by the derivative of the y with respect to x as we treat y as a function of the x. Similar to the right-hand side term, derivative of the y with respect to x is 1 times dy by dx. Now, we have two terms containing dy by dx. For the process, the step number 2, we are going to solve for dy by dx. We're going to collect the terms that contain dy by dx on one side. To be convenient, we're going to move 1/3 y to the negative 2x to the right-hand side and simplify the x term on the left to be x to the negative 1/2 equals 1/3 y to the negative 2/3 times dy by dx plus dy by dx. We are dealing with a negative power. We write in a convenient form. X to the negative 1/2 is 1/, square root of the x. For the second term on the right-hand side, the 1/3 multiplied by 1/y to the power 2/3 dy by dx. And since dy by dx is a common factor, we just factor it out. So in the parentheses, sharing the common factor dy by dx. And we write it as the single fraction for the quantity on the right-hand side that multiply to dy by dx. So now we have 3 y to the 2/3 as a common denominator. The first term numerator is 1. Second term, the numerator becomes 3 times y to the power 2/3 and multiplied by dy by dx. Therefore, the dy by dx obtained by multiplying both sides by the reciprocal of the quantity as a coefficient of the dy by dx to get 3y to the 2/3 divided by square root x multiplied by 1 plus 3 times y to the power 2/3. Next example. We have e to the power x plus y equals the tangent of the y. Our goal is to find dy by dx. Find dy by dx or apply the derivative to both sides of the equation. So d by dx of e to the x plus y equals d by dx of the tangent of y. The left-hand side, we have e to the power x plus y. And this is the composite function of the exponential and x plus y. We treat it by using the chain rule. So the derivative of the outer function, e as the outer function, x plus y is the inner function. We have e to the x plus y as a derivative of the outer function multiplied by the derivative of the inner function. So this one is the outer prime, and this is the inner prime. Equals the right-hand side. Again, we treat y as a function of the x. Therefore, the little chain rule is applied to the right-hand side term. The derivative of the tangent y is secant square of the y multiplied by dy by dx. On the left-hand side, we simplify a little bit of the derivative of the x plus y. Using the derivative rule, derivative of the sum is the sum of the derivatives. So the first term is dx by dx plus the second term, which is dy by dx, equals the right-hand side secant square y times dy by dx. Dx by dx is 1. Dy by dx is what we are looking for. So we are going to expand the product here by multiplying both terms with the e to the x plus y. So e to the x plus y multiplied by 1 to get e to the x plus y, and added by e to the x plus y times dy by dx equals the right-hand side, which is secant square of the y times dy by dx. Now we are going to collect the terms by subtracting both sides with the e to the x plus y, or you can do the other way around. But we can do this by leaving e to the x plus y on the left and move the e to the x plus y dy by dx to the right to get secant square y, secant square equals the secant square y minus e to the x plus y with the common factor dy by dx. And then we solve for dy by dx to get e to the x plus y divided by secant square y minus e to the x plus y, which is the dy by dx term that we are looking for. At this step, if you would like to see more steps, so I'm going to add it over here real quick. So I'm changing the color, another one, so you can see how it works out. So this is e to the x plus y equals secant square y dy by dx. And since you subtract both sides by e to the x plus y dy by dx, and both of them have the common factor dy by dx, we take it out as a common factor, and then in the parentheses, we have the coefficient of the dy by dx.